This is Chapter 3, Weight-Volume Relationships, Extra Example 1. For this example, we're given a soil sample taken below water table, which means the soil is likely saturated. And we also know the saturated unit weight 117 pound per cubic foot, and then the moisture content is 41%. We're going to calculate the void ratio, specific gravity, and the dry unit weight. So I'm showing on this slide the phase diagram for this problem. Because soil is saturated, so we only have two phases, and plus everything is given in terms of ratio, so we can safely assume volume. And for this particular problem, it's more convenient to solve or to assume total volume is 1. Now let's put the weight and volume side on this phase diagram and try to calculate all the weights and volumes on this phase diagram. So first of all, as I mentioned, it's more convenient to assume total volume is 1 for this problem. So let's put V equals to 1 on this phase diagram. And the reason that it's convenient to assume total volume because we know the saturated unit weight, gamma saturated. And if you recall the definition of saturated unit weight, gamma saturated is total weight over total volume. That's W over V. And this total volume is 1 by our assumption. So we can calculate the total weight W using saturated unit weight times total volume. So that gives us 117 pounds. So we can put this 117 on the phase diagram. And the next given information is moisture content, 41%, which is weight of water over weight of solid. And from this, we can calculate weight of water as W times weight of solids, which is 0.41, that's 41%, times weight of solids. Then the total weight W is weight of solids plus weight of water, which is WS plus weight of water is 0.41 times weight of solids. And this total weight is 117 pounds from our previous calculation. And there's only one unknown in this equation, that's weight of solids, WS. To be clear, W here is total weight. And from this last expression, we can solve for weight of solids, WS, that's 83 pounds. And once we know weight of solids, then weight of water is 0.41, that's the moisture content, times weight of solids. So that gives us 34 pounds. So we have both weight of solids and weight of water calculated. So we can put these two numbers on the phase diagram, 34 for weight of water and 83 pounds for the weight of solids. Now we need to cross over to the volume side. For the volume side, a common trick we use is if the weight of water is given, we can calculate the volume of water because unit weight of water is a constant and vice versa. So we're going to calculate first volume of water. The unit weight of water by definition is weight of water over volume of water. And from this we can calculate volume of water as WW over gamma W. If you plug in 34 for weight of water, and unit weight of water is a constant, 62.4 pounds per cubic foot, you get the volume of water, which is 545 feet cube. Once the volume of water is known, then the volume of solid is simply total volume minus volume water. And that's 1 minus 0.545. We get the volume of solid is 0.455 cubic foot. So that's basically the volume side. And because this is a saturated soil sample, the volume of the void is the same as volume of water, which is 0.545 cubic foot. Now let's put all these volumes on the phase diagram. So volume of water, 0.545, and then we have volume of solids, which is VS, That's 0.455. So that will give us a complete phase diagram. Once this step is done, then the rest of the problem is pretty straightforward, just basic definitions. Void ratio E, by definition, is volume of the void over volume of solid. And volume of the void is the same as volume of water for a saturated soil. And if you plug in these numbers from phase diagram, you get E of 1.2. And then for the specific gravity, gamma S over gamma water, so Ws over Vs over gamma water, and you plug in the weight and the volume from the phase diagram. Unit weight of water is 62.4, that's a constant again. And if you plug in all these numbers, then the specific gravity is 2.92, so that's GS. Finally, the dry unit weight, gamma D, is weight of solid over total volume. And again, using the information from phase diagram, just plug in number, we get dry unit weight is 83 pound per cubic foot. This problem can be solved by assuming the volume of the solid, Vs, is 1. For completeness, I'm going to include the solutions using Vs equals to 1, and you will arrive at the same final answers for void ratio, GS, and dry unit weight. However, it's much more complicated, and it's not recommended for this particular example. So the assumption here is volume of the solid, Vs, is 1 cubic foot. And again, on the phase diagram, let's put the volume and the weight side. And this is a saturated soil sample, so we only have two phases. Vs is 1 by our assumption. That's pretty much all we can put on the phase diagram for now. And then the total weight, W, is weight of solids plus weight of water. And then the moisture content gives you the relationship between WW, that's a weight of water, and the weight of solids. So we can write WW in terms of weight of solids. And then the total weight is written as weight of solids plus the weight of water. Next, we're going to use the unit weight of water, which is a constant, to calculate volume of water in terms of the weight of solids. So volume water VW is 0.41 Ws over 62.4. That's the constant unit weight of water. And to use the final piece of information, that is the saturated unit weight, we need to know the total volume. So the total volume V is volume of the solids, Vs, plus volume of water, Vw. And you just plug in the expression for Vw, so we get this expression for total volume in terms of Ws, weight of solids. And then now we can plug in the saturated unit weight definition, total weight over total volume. And saturated unit weight is given, which is 117 pound per cubic foot. And plug in the weight of solid and the total volume into this expression. The only unknown in this expression is weight of solids, Ws. So you can solve the weight of solids. So that gives you weight of solids, Ws, 182.5 pounds. Once you know weight of solids, then weight of water is moisture content times that. That's 74.81 pound. And the total weight is 257.3 pounds. Now let's put all of these values on the phase diagram. So we have this then completed phase diagram. And of course, the volume of water is weight of water over the unit weight, which is a constant. So that gives you the volume of water 1.2 cubic foot. And the total volume is V sub V plus V sub W. and that's 2.2 cubic feet. So now we have this phase diagram completed, then we can calculate the void ratio E, which is V sub V over V sub S, and then the specific gravity unit weight of solids over unit weight of water, and finally we can also calculate the dry unit weight, or gamma D, total weight of solids over total volume. So that gives us 83 pounds. Again, as you can now tell, this assuming Vs equals to 1 for this particular example makes it much more difficult to solve compared to the previous case where we assume total volume is 1. So this assumption of Vs or V being 1 is really problem dependent.